This past week, the Guadalupe River flooded again. More than 2 feet of rain fell across parts of the Texas Hill Country between Tuesday and Friday. The National Weather Service declared flash flood emergencies for at least 5 counties across southern and central Texas. A bridge over the Nueces River in Uvalde County collapsed entirely. Interstate 10 flooded near the town of Ozona, about 200 miles west of San Antonio. Rescue crews using boats and helicopters pulled more than 200 people from rising water across Uvalde and Zavala counties. John Mark Stewart, 65 years old, died in Kerr County when his recreational vehicle was swept into floodwater on the Guadalupe River near Comfort. A second person died after driving onto a flooded road near Uvalde. All summer camps in the area confirmed their campers were safe. That detail, a single sentence buried in every news report this week, lands differently when you know what happened on this same river 12 months ago. On July the 4th, 2025, before dawn, the Guadalupe River rose 26 feet in approximately 45 minutes. More than 10 inches of rain had fallen in a few hours across the watershed, sheeting off the rocky hillsides and pouring into tributaries that all drained into the same channel at roughly the same time. By the time the surge reached the stretch of river near Hunt, Texas, about 70 miles northwest of San Antonio, there was no warning and no time to react. Camp Mystic, a 99-year-old all-girls Christian summer camp that had served generations of Texas families, sat along the banks of the Guadalupe near Hunt. Some of its cabins were as close as 225 feet from the water. Roughly 750 girls between the ages of 7 and 17 attended each summer. The youngest campers were asleep in the cabins closest to the river when the water came. The river had been at normal levels when the girls went to bed. By 4 in the morning, it was inside the buildings. 25 campers died. The youngest were 8 years old. 2 counselors died alongside them. The camp's director, Richard Eastland, known as Dick, died while trying to reach the cabins to get the girls out. His family said he went toward the water, not away from it. The final death toll along the Guadalupe River that night reached more than 135 people. 13 of the camps along the river, according to a Texas Tribune investigation published in the weeks afterward, had structures built directly inside the Guadalupe River floodway. Camp Mystic was one of them. A 13-year-old camper named Eleanor Lester, one of those evacuated by helicopter as the water continued to rise, told the Associated Press afterward that the camp was completely destroyed. And now, 12 months later, the same river running through the same county has flooded again. The community still carrying the weight of last summer's losses spent this past week watching the water rise once more in the same creeks and the same valleys. The question that matters is not whether this will happen again. It will. The question is why this particular stretch of Texas floods like this. Why it has always flooded like this, and what actually changed between last year and this year that kept the second flooding from producing the same catastrophic outcome as the first. The answer starts underneath the surface. The Texas Hill Country sits on a geological formation called the Edwards Plateau. It is karst terrain, meaning the bedrock is limestone that has been shaped over millions of years by the slow-dissolving action of slightly acidic groundwater. The landscape above it is striking: rolling hills, spring-fed swimming holes, shallow rivers winding through rugged valleys. But beneath the thin layer of grass and cedar, the soil is shallow, sometimes only inches deep, and the clay-rich topsoil sits directly on top of limestone and granite that is essentially impermeable. Rainwater cannot soak through it. It has nowhere to go but sideways and downhill. Robert Mace, director of the Meadows Center for Water and the Environment at Texas State University, has described this drainage as hydrologically efficient. That phrase sounds clinical until you see what it means in practice. When rain falls on this terrain, nearly all of it becomes surface runoff within minutes. It sheets across the thin soil, gathers speed in creeks, and pours downhill toward the rivers through steep, narrow, V-shaped valleys that concentrate the flow the way a funnel concentrates liquid. The narrower the valley, the faster the water moves and the higher it rises. Researchers have compared the effect to putting a thumb over the end of a garden hose. The same volume of water passing through a narrower channel moves dramatically faster. That is the mechanism that allows the Guadalupe River to go from a gentle, shallow stream to a wall of water 26 feet high in under an hour. The watershed above it is steep, rocky, and laced with tributary creeks that all drain into the same channel. When heavy rain falls across the entire watershed simultaneously, all of those creeks deliver their runoff to the river at roughly the same time, producing a surge far larger and far faster than the rainfall totals alone would suggest. But the geology is only half the equation. The other half is the atmosphere above it. The hill country sits at the eastern edge of the Balcones Escarpment, a line of cliffs and steep terrain created by a geological fault that runs through the heart of Texas from near Waco, south through Austin and San Antonio, and westward toward Uvalde. The escarpment raises the elevation by nearly 1,000 feet in some areas, When warm, moisture-laden air from the Gulf of Mexico flows north and west across the coastal plains and hits that wall of rising terrain, the air is forced upward. As it rises, it cools. As it cools, the moisture it carries condenses. The result, under the right conditions, is an intense concentration of rainfall directly over the escarpment and the hill country just west of it. Meteorologists call this orographic enhancement. The terrain itself wrings moisture out of the atmosphere, the way a hand wrings water out of a sponge. And it happens in the same place, over the same geology, feeding the same rivers, every time the atmospheric pattern aligns. That convergence of impermeable bedrock below and orographically enhanced rainfall above is why the region has a name that appears in National Weather Service training materials, FEMA flood planning documents, and academic hydrology research, Flash Flood Alley. A crescent of terrain curving from near Dallas down through Austin and San Antonio and westward to Uvalde that has produced some of the most rapid and deadly flood events ever recorded in the United States. The pattern is old. In 1987, heavy rain in western Kerr County flooded the Guadalupe River and killed 10 teenagers who were being evacuated from a summer camp. The Blanco River near Wimberley rose 40 feet overnight during the 2015 Memorial Day floods, killing 13 people and destroying more than 350 homes. Weeks before the Camp Mystic disaster, a June 2025 flash flood in San Antonio killed 13 people whose cars were swept off a highway frontage road before dawn. A forest ecologist at the University of Texas named William L. Bray documented this exact problem in 1904, 122 years ago. He described the Edwards Plateau's steep, dissected terrain as producing floods of such volume and velocity that only heavy vegetation could slow the water enough to prevent destruction. That assessment was published before the automobile existed, before any of the highways, bridges, RV parks, and summer camps that now sit in these floodplains were built. It remains perfectly accurate. There is a layer on top of that geological constant that is accelerating a problem. A warmer atmosphere holds more water vapor. The Clausius-Clapeyron relationship, a foundational principle of atmospheric physics, predicts roughly 7% more moisture for every single degree Celsius of warming. When that extra moisture gets wrung out over terrain that was already the most flood-prone in the country, the result is disproportionate, because the geology that cannot absorb a 6-inch rainfall also cannot absorb a 7-inch rainfall. But the difference in runoff volume and river rise between those two numbers on impermeable limestone is enormous. The terrain amplifies the increase. University of Texas at Arlington's civil engineering professor Nick Fang, describing the hill country's geology during this month's flooding, stated it plainly. The ground is granite and limestone. Rainfall has nowhere to go but downhill and into the rivers as quickly as gravity allows. So what actually changed between last July and this one? The geology did not change. The rivers followed the same paths they have followed for millennia. The atmospheric setup was broadly similar, with slow-moving storms feeding off Gulf moisture and dropping heavy rainfall across the same watersheds. But three things were different, and the gap between 2 deaths and more than 135 is contained almost entirely within them. The first is timing. Last year's flood arrived before dawn. The most intense rainfall hit the Guadalupe watershed around 4 in the morning on July the 4th when most people were asleep. This year's flooding developed over several days, with the heaviest rain arriving during daylight hours. People could see the water rising. They could see the roads closing. Visibility changed the survival math. The second is warning. After last summer, communities across the hill country invested in early warning systems specifically designed for the kind of rapid river rises this geology produces. Jason Runyan, warning coordinator, meteorologist with the National Weather Service Office for Austin and San Antonio, told the Texas Tribune that forecasters began briefing local officials starting on Sunday, 4 days before the worst flooding arrived. Flash flood warnings were escalated to flash flood emergencies in real time. People had time to move. The third is the nature of the storm itself. Texas state climatologist John Nielsen-Gammon described last year's event as extremely flashy, with intense rainfall concentrated in a short period over a narrow area. This year's event was broader geographically and spread over more days. Total rainfall was arguably higher. Some areas received more than 2 feet, but the rate at which that rain arrived was lower. And in flash flood hydrology, rate matters more than total. A slower storm over the same geology produces a lower, wider flood peak rather than the single violent surge that overwhelmed the Guadalupe in 2025. Initial hydrograph data from this year's event actually showed higher river levels at some gauges than 2025, but the rise was gradual enough that people could see it coming and act. The river was lethal both times. The difference was visibility and time. The National Weather Service guidance that applies to both events has not changed in decades and remains the single most consequential piece of information in this entire story. Turn around, do not drown. Roughly 1 foot of moving water can sweep a car off a road. Roughly 2 feet can float most vehicles entirely. Every death on a flooded road in Flash Flood Alley follows the same physics. The warning systems that saved lives this year were built because more than 135 people died last year. The forecasters who briefed officials 4 days early did so because they had watched the same atmospheric setup produce the same result 12 months before. Those systems and those people are the only variables standing between the geology and the next disaster. The limestone underneath Kerr County and Uvalde County and the Guadalupe River Valley will be the same limestone next July that it was this July and last July, and in 1987 when 10 teenagers died on the same water. The geology does not reset between floods. It does not erode into something safer. It guarantees the flood. The only thing that has ever reduced the death toll on this terrain is the distance between the moment the rain starts and the moment someone acts on a warning. Every hour of lead time, every family that moves to higher ground before the water reaches their road, every driver who turns around instead of crossing a flooded low-water crossing is a life the geology would have otherwise taken. Camp Mystic had announced plans to partially reopen this summer for its 100th anniversary. The Guadalupe River they would have returned to is the same river it was before last July, the same river it was before this July, the same river it will be next July. The limestone underneath it does not know what year it is. The communities rebuilding along the Guadalupe are not rebuilding in a floodplain by accident or ignorance. They are rebuilding on terrain they understand, in a place their families have lived for generations, beside a river that is gentle and beautiful almost every day of the year. The danger is not the river. The danger is the handful of hours each decade when the sky above it and the rock beneath it conspire to turn it into something else entirely. And those hours arrive on the same geology, through the same mechanism, in the same valleys, in the same way they arrived in 1987 and 2015 and 2025. And this past Tuesday. Subscribe so you do not miss what we cover next. See you in the next one.